Hello, welcome to our channel. In this video, we will talk about odd and even functions. Here are the definitions of odd and even functions. An even function is simply a function that has a graph symmetric about y-axis. So to test if a function is even, we just need to replace x with negative x and see if we get the same equation. Or in other words, we must have f of negative x equals f of x. Similarly, odd function is a function whose graph is symmetric about the origin. And to test if a function is odd function, we replace x with negative x and y with negative y and see if we get the same equation. Or in other words, we need to verify that f of negative x equals negative f of x for a function to be an odd function. Let's look at this example here. So we are given y equals x to 4 plus 12 x squared minus 10. So to decide if this function is odd or even or neither, we want to start by evaluating f of negative x. So if that f of negative x comes out to be f of x, then it is even. If f of negative x comes out to be negative f of x, then it is odd. So f of negative x is negative x to 4 plus 12 times negative x squared minus 10. Negative x to 4 is simply x to 4 plus 12 times negative x squared is simply x squared and minus 10 as it is. Now you see x to 4 plus 12 x squared minus 10 is exactly what we have over here. So this is simply f of x, given f of x. So we just saw that f of negative x is same as f of x. So that satisfies this condition here. Therefore, this function is even. Let's look at the next example now. So here we are given y equals 3x cubed plus 10x as the second example. So we want to again evaluate f of negative x and see if that will come out to be f of x or negative f of x. So this is 3 times negative x cubed plus 10 times negative x. So this is negative x cubed is negative x cubed. So this will be negative 3x cubed minus 10x. So here we can factor out negative 1. It will look like negative all the way in the front, 3x cubed plus 10x. And you see this 3x cubed plus 10x is simply the given function. So this I can write as negative f of x. So it looks like this condition is satisfied here, f of negative x. We got that to be negative f of x. So therefore, we can say this is odd. This function is odd. The next one here, again, we start by calculating f of negative x. So this becomes 3 times negative x to 4 plus 10 times negative x. So this is 3x to 4 because negative x to 4 is x to 4 minus 10x. Now, if you compare this one with that one over here, 3x to 4 is 3x to 4 as it is over here. But for 10x, we get negative over here. So this is not f of x, definitely. And this is also not negative f of x. For it to be negative f of x, both of these have to be negative. So none of these two are satisfied. This is not satisfied and this is not satisfied in this case. So this is neither even or odd. So we're done with these examples also. And here we have more examples. In this case, we are given graphs and we want to decide if these represent odd or even functions. So we said a function is odd if we have symmetry about origin, and function is even if we have symmetry about y-axis. So based on that, we can decide if the function represented by a graph is odd or even. So if you look at the first one, it's definitely symmetric about y-axis, because for every point here, we have a point here. So we can say this is even. For the second one, it is symmetric about the origin, because for every point here, we have a point here. So each point is being reflected about the origin. So this one is odd. The third one is not symmetric about y-axis, because for this point, we don't have a point over here. It's not a reflection about y-axis, and it's not symmetric about origin either. For it to be symmetric about origin, for this point here, we must have a point here, which we don't. So this is neither odd nor even. The fourth one, it is symmetric about origin, because, for example, for this point here, we have a point over here. For this point here, we have a point here. It is symmetric about origin, so this is also odd. This one looks like symmetric about the y-axis. So if you rotate around y-axis, you get the same function. So this is even. And this last one does not have any symmetry. So this is neither even nor odd. So it's very easy to determine if a graph represents an odd function or an even function, just by looking at their symmetry. So we are done with these examples, and this is all I have put together in this video. Thank you for watching. See you in our next videos.